If you're writing NECO this year, I want to show you everything you need to know about your physics practical. So take your notes and take your pen so that you follow every single thing I'm going to be giving you. Of course, this is a model practical, but it's going to look like what you're going to see in your exam also. It's not the exact thing. So let's see the apparatus that we have. Actually, I have my own experimental setup here. Everything is like set up in this place. So I'm going to be using this for my lab experiment. So we have the apparatus, we have the helical spring. So as you can see, I have my own helical spring right here. Then we have a set of masses. I have my mass here. So with this, I can actually vary the mass as it goes on and on like that. So I can vary the masses. So take note of that. Then what else do we need? We need a meter rule. So you can see my meter rule is here already. What else do we need? We need a retort stand with clamp, and we need a stopwatch as well. So I have my retort stand here. That is what is already clamped here. Your teachers are going to guide you in how to set up your experiment. They will not do the experiment for you, but they're going to guide you on how to do the experiment itself. So now let's get right into it. What's the first step? It says set up your retort stand and suspend the helical spring from the clamp as shown in the diagram. I'm not putting any diagram here. I've already, like, you can always see what the setup looks like here. So this is the setup. This is what it's going to look like. And it says, step 2 says attach a mass M, which is equal to 100 gram, to the free end of the spring and allow it to reach its equilibrium position. So basically what that is saying is that you attach a mass M. So I already have my mass M, which is 100 gram here. So in this situation, I do not intend for it to be rolling up and down. I just want to make it extend from the free end. So you can see that initially, so let me remove the mass. Initially, if you notice now, the ruler was here, just at the very tip of this place. This is the resting point when there is no mass on it. But the moment I place a mass on it, now, so one thing you have to do is that once you place a mass on your spring, it will start oscillating like this. So with your hand, you can stop it and let it stop moving. So, but for me, I can stop mine like this now. So it is already stopped moving like that. So for this now, the question says we should record the extension. Record the extension for the 100 gram. Record the extension for the 100 gram. So I'm going to trace it now. This is in centimeters. So you can see that this is 10 centimeters. This is going to be between 10 and 20, we have 15 centimeters. So this is approximately 15 centimeters. So you record the length that is close to the tip of that mass, not the entire length that is close to the tip of it. So from the original position to this place, you have something approximately 15 centimeters. So the extension there is 15 centimeters. So I've recorded that already. The next one says displace the mass slightly downward and release it so that it oscillates vertically. So what is this actually talking about? Is it wants us to displace this mass. Once I displace it now, it will start oscillating up and down. It will start oscillating up and down. So you can see that the mass is oscillating. So what you need now is, I'm going to keep this ruler for now. Let's now see what the next part of the experiment says. Once it does that, it says measure and record the time t for 20 complete oscillations. Time t for 20 complete oscillations. Now, what is oscillation? Oscillation is a to and fro. So you can either start from the top or you start from the downward. So when you're starting from top, you wait for it to go down and come back up. That's one oscillation. When you start from down, you wait for it to go up and come back down. That's also a complete oscillation. So you can do it any of that. So you repeat this counting for 20 times. And then what you do is that you record the time it takes. So just watch as I'm going to do this now. I'm going to activate my stopwatch at any point in time once it goes up now. So let's see. Once it goes up, I'm going to hit the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've been able to record the time for 20 oscillations like that. I've been able to record the time for 20 oscillations. So I'm going to go to my table. I've already set up my table already. So this is what your table will look like. The masses are 100 gram, 150 gram, 200 gram, 250 gram, and 300 gram. So I'm going to record there. I got 16.5 So on my stopwatch I had 16.13. 16.13. Okay, so let's proceed. That's that. It says evaluate the period and then evaluate t squared. Don't worry, we'll do this one. Let's complete the time. We'll come back to those period and everything. So repeat the procedure for 150 gram, 200 gram. So that means that I want to be changing the masses now. I want to be changing it to from 150 gram to from 100 gram to 150 gram until I reach 300 grams. So let's go. I'm going to stop this right here. So this mass, I'm going to pick another mass now. In this case, I want it to be 150 grams. 150 grams. So I'm going to pick 150 grams. I don't need to measure any extension or anything now. So I'm going to stop it for now. So for now, I'm going to repeat the same thing I did earlier. So let me reset my stopwatch now. So I'm going to displace it down. So displace it down. Be careful. Don't displace it too much, because if you displace it too much, the whole thing might just flip off the table. So I'm going to displace it downward. So let's see. So it's oscillating now. Once I'm ready, I'm going to start counting. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 19.82 like that. So I have 19.82. So let's go again. The next mass is going to be 200 grams. So I'm going to be fast now since I've explained what the process is already. So I'm going to stop this one now. We have a mass of 200 grams. That's the next one that is going. So I'm going to stop this and I'm going to displace it a little. So allow it to, go up and down until you are ready. So you hit your stopwatch the moment it is up. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got 22.88. So 22.88. So now we're going for the 250 grams. 250 grams. So I'm going to drop this mass now. 250 grams now. Don't forget, reset your stopwatch. Hold this down. Just displace it down a little bit. So once we are ready, I'll go. You can see that it's becoming slower. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's 25.60. 25.60. Now to the last one, which is 300 grams. So reset this, pause this, drop this, and take it to 300 gram mass. So I'm going to hang this right here. Yeah, so I'm just going to displace it a little bit. Okay, so let's go. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 27.95. 27.95. So now that I've gotten everything now, I'm done with the experimental part now. So I can forget about this experiment now. I'm done with anything I need from this experiment. So the next thing is for me to go to my table reading and then do all the necessary calculation. So from here, it says, remember here it says that when you're done with that, hence evaluate the period t. So I've already given the formula here. Period t is simply the time taken divided by 20. So you divide every single time here by 20. So I'm going to do that with my calculator now. So to determine the period for each, divided by 20. This one is 0.8065. 8065. 19.82 divided by 20, that's 0.9910. 22.88 divided by 20, that's 1.1440. Then 25.60 divided by 20, that's 1.2800. Then 27.95 divided by 20, that's 1.3975. So the next thing I need to do is to be, now you can see now here it says evaluate the period, and next step is to evaluate the square of the period. So I'm going to be squaring each of these now. So 0.8065 squared, that is 0.65. So I'm going to be using this t square as in two decimal places. So 0.9910 raised to power 2, that's 0.98. 1.1440 raised to power 2, that is 1.31. Then we have 1.28 raised to power 2, that's going to be 1.64. 1.64. Then we have 1.3975 raised to power 2, so that's 1.95. So now with this, now I have everything that is needed for the table. So tabulate your reading as shown in the table below. I've done that. Then now we want to plot the graph of t squared on the y-axis and m on the horizontal axis. So I have my graph down here already. So we want the graph of t squared on the y-axis, t squared, which is in second squared, and we have a point here which is m in gram on this axis. So this is what we are plotting as our graph. So the problem now is that we need to choose a very good scale so that we get a perfect graph in this situation. So you can see that in this place you have 0.65, you have 0.98, you have 1.31, 1.64, 1.95. Now, you begin to look at it very well. This scale, if you decide to say something between 0.5, and then if it is increasing with 0.5, from after 0.5, the next thing is going to be what? Is going to be 1.0. Next thing is going to be 1.5. Next thing is going to be 2.0. Now, that is too close. So you can, too far. So you can bring it down a little bit and make sure that the values are actually wide apart for your period. So you have 0.65, you have 0.98. Although there's a way to do this, to know a closer scale to use, to know what to use for each box, what you use that, just subtract the smaller number from the bigger number. So that's 1.95 minus 0.65. Now, go and count the box. So t square is to be on the vertical axis. So go and count the number of boxes that you have for the vertical axis. So in this case, you are going to have 1, 2, 3, 4, 5, 6, 7, 8. I'm talking about the big boxes now. So you have 8 here. In that situation, so just divide this result by 8. Divide this result by 8. So 1.95 minus 0.65 divided by 8. So in this situation, I have 0.16. That is approximately 0.2. So I'm going to be using 0.2 for my scale now. So for every little one there, I'm going to be using 0.2. So this could be, so this can go from 0.2 to 0.4 to 0.6 to 0.8 to 1.0 to 1.0 to, and so on like that. But to save myself a lot of stress, I'm just going to start from 0.4. So I'm going to start from 0.4. Why am I starting from 0.4 is that my first value here is 0.65. So I'm going to start with 0.4. I could even start with 0.6 itself. I think 0.6 is a very safer option to start with. So I'm going to start with 0.6. So this place, I'm going to say, so this is 0.6, 0.6, 0.8. This is 1.0, this is 1.2, This is 1.4, this is 1.6, this is 1.8, and up here is going to be 2.0. So I don't want to get to that place anyways. My result will not get to that place. Then the next one is for the x-axis, so you can do the same result. So this one is very easy. Just use 50, scale of 50, and start from 100. So from this place you can have, like, let's say 100 is here, so let's say 100, 150, 200, 250, 300. So that makes sense. 100, 150, 200, 250, then you have 300. So now this scale is perfect now. So what you begin to do is that you begin to look at those values one after the other. So you have when the mass is 100, you have 0.65, 0.65. So by the way, look at my boxes here. I have 1, 2, 3, 4, 5. So between 0.6 and 0.8, I have 5 boxes between 0.6 and 0.8. Just do this: 0.8 minus 0.6 and divide it by 5 boxes that I have. So when I do that, divided by 5 boxes, that's 0.04. It means that each box is going to be 0.04. So if I move from 0.6 now, this is going to be 0.64. This is going to be 0.68. Now the next one is going to be 0.68 plus 0.04. So what is 0.68 plus 0.04? That will be 0.72. So let me confirm that. 0.68 plus 0.04. Yes, that's 0.72. So that implies that if I go further again, I will have 0.76, then until I get to 0.80. So what is the value I need to put here is 0.65. 0.65. So let's see. From 0.60 to 0.64. Now the next one will be 0.68. So that means that my 0.65 is going to be somewhere around here. Somewhere just a little bit above the 0.64 line. So this is going to be... So you can just put a tiny dot there. Then for 150, what do we have? We have 0.98. So let's go. 0.98. So this is 0.8, 0.84, 0.86, 0.92. No, this is 0.8, 0.84, 0.88, then 0.92. Very good. Now 0.96, like that. And I'm going to 0.98. So 0.98 is going to be somewhere around here. Somewhere around here. My graph is not perfect, so I'm unable to do those tiny readings. This is just a demo, so just pay attention to that. The next one is 1.31, 1.64. So let me just pay attention to that. 1.31, 1.64. So for 200 gram is 1.31. So this is 1.2, 1.24, 1.26. Sorry, 1.28 rather. Then this will be 1.32. So this will be somewhere a little bit below here. Then 1.64. This is 1.6. Okay, perfect. This one is going to be exactly on this place. Let me delete these two. So we take the last reading now. So the last reading is 1.95. So 1.95, this should be 1.8, 1.84, 1.88, 1.92, then 1.96. So 1.95 will be somewhere around here. So with this now, I've been able to get that. So now the next thing I want to do now is to draw my graph. I need to draw my graph now. Now, this seemed like a very perfect thing. Normally, it will not always be perfect in the exam hall. So because what I'm using, what I used for my experiments, you can see what I used for the experiment. It's a perfectly set up system. You're going to have a little bit of discrepancy in your stuff. So now I'm going to draw the graph now. So how do we draw the graph? When you want to draw a straight line here, it doesn't necessarily have to touch. In fact, it may not touch any of the lines. The only thing you have to make sure is that your line is close to all of the points as much as possible. So for instance, I can decide to draw mine like this. Just watch it. Now with this my own line now, this is a perfect line. it did not touch everything. Yeah, it touched like 3 of them, but my intention was not even for it to touch the 3 of them. I just wanted to touch like a few of them and all of that. So that is exactly the graph for this thing now. So I've been able to draw the graph now. So what's the first question from there? It says determine the slope S of the graph. So determine the slope. Always pick something convenient, something that you can easily read the point. For example, now if I were you, I would pick somewhere like this. So let's see, I think I should use, so I'll pick somewhere something I can easily read. Okay, I think this place is good. I can pick these 2 points. So this is number 1 point, and I can pick a second point right here as well, So with that now, I will trace this thing down. I will trace this down. So let me change this. I will trace this down. Yeah, so I'm going to trace this down now. So this is going to be to this place. This is going to be to this place. Then I'm going to trace this other second point too. I'm going to trace it down. I'm going to trace it down. So it's to this place. Then I'm going to trace this one right to this point. So I'm going to take note of those 2 points now. I'm going to take note of those 2 points. So I have, for this one, the x-axis, so you're going from 150 to 200, that's 50. So meaning that each of these will actually take 10 10. So 150, 160, 170, 180, 190, 200. So this will be 160, 170, 180. So this point is point 180. So this is point 180, comma, so, and what is there? 1.2. So I've been able to pick the first point now. Now the second point is on 250. So I have 250, comma. Now this is 1.6, this will be 1.64. So this is 1.64. So after picking that now, I've been able to pick these 2 points now. So the question says we should find the slope. So what is slope? To find the slope is simply change in the vertical divided by change in the horizontal. So the slope is going to be change in y over change in x. So that is what is your first y value. You can pick this one as the first y value and pick this one as the second one by y value. That's 1.64 minus 1.2 divided by, now 250 minus 180. 250 minus 180. So 1.64 minus 1.2, that is 0.44 divided by 250 minus 180, that's 70. So when you do that division, 0.44 divided by 70, that is going to be 0.00629. 0.00629. So that is the slope. We have been able to find our slope. Now, one thing you also need to do is that you need to know the unit of your slope. So first of all, what's the unit of this y-axis? It is second squared. What's the unit of the x-axis? It is gram. So therefore, this slope that we just got now, so let me bring it right here. This slope that we just got now, slope S, is in second squared per gram. Now we are moving on. It now says evaluate the spring constant using this. We want to evaluate the spring constant now using this. Now one thing we need to notice there is that our spring constant, normally it's supposed to have a unit that is familiar. You know, your spring constant, you say F equals KE. So spring constant is always Newton's per meter. But in this situation, we're actually not going to have Newton's per meter because what we are dealing with is gram, not kilogram. We did not work with kilogram throughout the whole thing. So the unit we have to correspond with the unit of the slope based on everything that we're putting in here. So calculate the spring constant, which is K. So K equals 4 pi divided by S squared. K equals 4 pi squared. 4 pi squared divided by S. So that will be 4 multiplied by, so let me just press everything on my calculator. 4 times pi, raised to power 2 divided by what's my slope? 0.00629. 0.00629. So with that now I have 6,276.38. Now what will be my unit now? I'm dividing with the slope. So that means that 4 pi squared does not have any unit. It's a constant. So my unit for this spring constant now will now be excuse me please, will be gram per second squared. Why is that so? Because this is the inverse of slope in this place. So the unit is going to flip now to become, it's going to flip and become gram per second squared. So I've been able to find the spring constant like that. So take 2 precautions. I believe you should be able to do that on your own. That's it. From your graph, determine the period of oscillation when m equals what? 175. So what is 175? How do we get 175? I've already told you that each of the boxes in my own case now signify 10, 10. So 175, so this is 150, 160, 170, 180. So this middle here is going to be my 175. All I'm going to do is that I'm going to trace this thing up until it touches the graph. So it touches it here. So I'm going to trace it down to this place. So what point is that? We have 1.0, 1.04, 1.08, 1. After 1.08 we have 1.12. Yes, we have 1.12, and then we should have 1.16 here. So yeah, 1.16. So the square of the period at that when the mass is 175 is 1.16 seconds squared. What I'm looking for is the period. So I'm going to find the square root of both sides. So t is going to be square root of 1.16, and that is going to be 1.077 seconds. And that's actually everything you need to know about this practical. So this is similar to what your practical is going to be like. And if you need any further clarification, just let me know in the comments. Also, make sure you subscribe to the channel if you find this video very helpful. So that's it for now. I'll see you in the next one.